Hi, I'm Xinyue Zhang. This video is the second report for my class project. My class project is fatigue analysis of a variable section cylinder. This is the mechanical behavior of materials class project. And the second report was posted on October 31st, 2018. Objective. My project is to run a fatigue analysis of a variable section cylinder, which is often used in different kinds of engineering structure. The reference video is fatigue analysis of a plate with hole using ANSYS Workbench. This 3D model was created using Creo. The analysis was run using ANSYS Workbench. Introduction. The fatigue analysis is one of the main forms of failure of mechanical components. Fatigue is the degradation of mechanical properties leading to failure of a material or a component under cylinder loading. In my first report, this project used ANSYS Workbench to run a fatigue analysis of a variable section axis in two conditions. One is applying force only, the other is applying moment only. Using the solution tools in Workbench, this project got the result of total deformation, equivalent stress, life and safety factor. After the first test, I moved forward my project, and this time I applied different load on the same model on the other model to find the maximum load it can withstand. This is my materials model. My material is the default material in Workbench. It's structured steel. The stress life curve is shown on the right. It's something like this. This curve means if the result point is under this curve, the structure would be safe, and if the position of the result is above this curve, it means the structure is not safe and it needs some change. This project used the mean stress theory. It's Goodman theory. The constant amplitude load curve is like this, and the Goodman theory curve is something like this. First, I use a random variable section cylinder to test this fatigue analysis tool. The boundary conditions is like this. I add a fixed support at this side of this cylinder. This is the test result in my first report. I applied 500 kilonewton force on the end of this axis. The deformation result is like this. The maximum deformation is about 4.5 millimeters and minimum is 0, which means this point will not have deformation. This is the equivalent analysis result. And the maximum is about 88 megapascal. The minimum is about 3.5 megapascal. The life is about 1e6 number of cycles. The safety factor is 3.881, which is more than 1 based on the Goodman theory, which means this structure is safe. And I think the load I add on this structure will be too small. For the second condition, I add a moment at somewhere near here. The second condition, I applied 500 kilonewton millimeter moment on the end of the axis. The deformation result is as follows. The maximum deformation is about 0.82 millimeters. The minimum is 0 millimeters. And the equivalent stress analysis result is as follows. The maximum stress is about 52 MPa and the minimum stress is about 14 MPa. And the life is also 1e6 number of cycles. The safety factor is about 2.78, which is more than 1 based on the Goodman theory, which is also means it's safe under this value moment. After the first test, I designed my own variable section cylinder. The 2D dimension is like this. And I create the 3D model using this dimension in Creo. From my previous test, I know that the dangerous part will be at the point at the fixed end. It's somewhere like here or somewhere like here. So the mesh should be more meticulous at this point than the other section. Then I run a very similar analysis like my first test, and I got the result like something like this. We can see the dangerous point is still somewhere like this. And I got the life and the safety factors also. As this is the student version software, I cannot use this mesh model, so I surprise my refinement. This is the result. I applied several forces on this model, and I got several safety factors and plot a curve like this. And I use the trend line in Excel to simulate this curve. The equation is like this. From this data, we can see if the structure, if we require the safety factor is 1, the maximum force we can apply is from 1900 kilonewtons to 1950 kilonewtons. And I applied 1925 kilonewtons as well, and then I got the number like 1.0083, which means that the maximum force can be applied on this model should be 1925, should be about 1925. Also, we can use this equation to calculate the maximum force we can apply. On my next report, I will try the moment condition and get several moment versus safety factor results. Discussion. For general part, there is no theoretic formula to solve fatigue analysis problem, and fatigue and finite element analysis technology is an efficient way for these problems. According to the results of my first test, we can see that the point at the fixed end is most dangerous. Thus, engineers should pay more attention on this point to make sure the structure can be safe. Also, if they are not sure with the safe force, they can try several force to test and gauge the safety factors. If as the 50 factor is 2, the maximum force may be no more than 1000 kilonewtons. That's all my second report.